So, without wasting time, let's start with the first chapter of class 12 revision. And the first chapter is electric charges and field, and it includes the fundamental concepts related to electrostatics. It deals with the electrostatic force, charges, and its properties and interaction between the charge and the field. So the first chapter actually deals with the fundamental concept of static electricity. Okay, static means anything that doesn't move with respect to time. And the first chapter deals with the properties of charges, the properties of electrostatic force, and it deals with the fundamental properties of electrostatic force. So without wasting time, let's revise it firstly, because I have class from 9 a.m. So what is a property? At first, what is a property? So our first chapter deals with the properties of charges, properties of its nature of charge. Okay. So the properties, it deals with the means the characters. Properties means only characters. So when there will be any properties, there will be effect. And the example of property is mass. Example of property can be charge. And though mass is a property, obviously property will lead to effect, and effects can be gravitational force, electrostatic force, and so on. So mass is a property, and mass effects are gravitational force, moment of inertia. So what is the formula of gravitational force? The formula of gravitational force is F equal to G m1 m2 by r square, and the formula of moment of inertia is m r square. So mass is a property, and property will result in effect. Charge is also a property, and it is a physical property. It is a physical property because it cannot be visible, and it's not a chemical property, means charge is not a chemical property. So sorry for the chaos. Okay, so charge is a property, and its property led to effects, and if its effect example is electrostatic force. What is static? Statics, that means anything doesn't move or change with respect to time. Okay, so if there is no property, there will be no effect. And what is mass? Mass is a property, and that property will lead to effect. And mass is a quantity of matter that contains in a body, and obviously mass has many composition. And property of an object due to which it apply or experience gravitational force is always attractive. So gravitational force is an attractive force, and mass is a property, and its results will be in effects, and effects example is gravitational force, moment of inertia. Charge is also a property, it will lead to a effect, and its effect example is electrostatic force. So charge is a physical property, charge is not a chemical property. It is not a chemical property because because charge is not visible, so that's why it's a physical property. So how a body may charge? A body can be charged by giving some electrons and taking out some electrons. Why it is electrons? Because electron has no strong bond. Though electron has no strong bond, it can be transferred, and proton cannot be transferred because proton is bonded with nucleus, and is bonded with strong nuclear force. That's why it cannot be transferred. And charge has three state. First one is rest of charge. Second one is charge moving with constant velocity. When the charge is moving with constant velocity, there will be means the charge is moving slowly. And when the charge is moving in accelerated manner, that means the charge is moving in faster way. So there are three state of charge. First one is the rest of charge, second one is the charge moving with constant velocity, and third one is the charge moving with accelerated manner. So when there are three state of charge, when the charge moving means sorry, when the charge is at rest, it will lead to effect, and its effect will be electric field. And the charge is moving with constant velocity, its effect will be electric field and magnetic field. And when the charge is moving in accelerated manner, its effect will be electric field, magnetic field, and EM wave. So, and some important points of charge, like what is the uh, the charge of an electron is minus E, and that is minus 1.6 into 10 to the power minus 19 coulomb, and its sign is negative. And the charge of a proton is plus E, and that is plus 1.6 into 10 to the power minus 19 coulomb, and its sign is positive. So the charge of an electron and protons are same, because the negative and positive sign indicates the property, it does not indicates the value. That's why their charges are same. And the charge of an electron, charge of an proton, charge of a proton, charge of a positron, and charge of a deuteron are same, and that is positive plus E, and 1.6 equal to 1.6 into plus 1.6 into 10 to the power minus 19 coulomb. And charge of a neutron is 0. So for an atom is denoted if we draw the structure, means diagrammatic structure. It's not like this structural. If you draw atoms, not the atoms like if we consider an atom like helium, and He, that is helium, and below helium we write 2, and in the upper, like the power, we write 4. So it in the 2 is the atomic number and 4 is the mass number. Similarly, we consider, instead of helium, we consider is considered as X. So X is the atoms or element, and Z is the lower end, that is the atom number or the proton number or the electron number, and A is the mass number, that is the proton number. Okay, and what is the formula of finding out number of neutron? And that will be A minus Z. Now the charge of a, for example, a question can be given like that. A charge of a 10 electron can be written as Q equal to minus 10, E equal to minus 1.6 into 10 to the power minus 19 coulomb. And charge of an half electron, charge on half electron can be it is 0. I'm sure, because charge of a half electron, half means it is in fraction, and so when the n value is in fraction, the charge will be 0. And when the fraction value is in large value, will, when the fraction value is high, like 7.5 into 10 to the power 17, then the charge value will not be 0, and the charge on 7.5 into 10 to the power 17 electron will be minus 7.5 into 10 to the power 17 into 1.6 into 10 to the power minus 19 coulomb. Okay, and that is the thing. So to find the net charge, we have to consider proton, electron, and neutron charge. Charge can be two types. One is positive, second one is negative. When there will be positive charge, that means there is deficiency of electron, and when there will be deficiency of electron, obviously the mass number will be decreased. And charge can be negative, and when there is a negative charge, that means there will be a grain of electron, and when there is grain of electron, their mass number will be increased. Charge cannot exist without mass, but mass can exist without charge. Yes, some important relation with the charge, that is 1 coulomb equal to 3 into 10 to the power 9 ESU, and 1 ESU equal to 1 by 3 into 10 to the power minus 9 coulomb. And we have read about force. And the SI unit of force is Newton, and the CGS unit of force is Dime, and 1 Newton equal to 10 to the power 5 Dime. The smallest unit of charge is ESU, and that is Franklin, and the largest unit of charge is Faraday. It's not Farad. Farad is the unit of capacitor. So how a person get electric shock? But person get electric shock by discharge of electric charge through our body, which are accumulated on rubbing with the insulated surface. So what is static? Anything that doesn't move or change with time, that is known as static. And electrostatic deals with the study of force, study of field, and study of potential. Electrostatic arises from the charge. I'm not the ma'am, I'm a student. Okay, I'm not teaching anyone, I'm just revising my chapters. So the source of charge is electron, and some special property of charges are source of charge is electron, and charge is denoted by Q, and charge are of two types. First one that is positive and negative. Charge is not visible, that's why it's a physical property, and charge is a property. Obviously charge is a property. Mass is also a property, and charge is conservative in nature. Conservative means anything, the charge cannot be created nor be destroyed. Charge can neither be created nor be destroyed, but it can be transferable. That means that is a property of conservation of charge. The total charge of an isolated system is always constant. Charge is quantized. Okay, and charge is additive in nature, and SI unit of charge is coulomb, and CGS unit of charge is ESU. Charge is quantized means anything which is available in the market, and it's a fixed amount. It is in fixed amount. Quantized means anything which is available in the market. I'm just telling in my own words, because you cannot ask to a shopkeeper that give me half pen. So you have to ask me 1 pen. Similarly, charge is quantized means it is available in the market, and it is in fixed amount. And charge always exists in integral multiple of fundamental charge. That is, integral multiples means 1 2 3 4 5 6, and that means the whole number. You can consider it as a whole number. And the formula is Q equal to NE. Q means the charge of any body, and N means the integral number, and E means the charge of a proton. So my teacher has given one question, that can a body of plus 8 into 10 minus 18 coulomb can be given in a body. Obviously, if we put the formula Q equal to NE, N equal to 8, Q equal to NE, and Q means charge of any body, and the charge is already given, that is plus 8 into 10 minus 18 coulomb, and we all know the charge of an electron is 1.6 into 10 minus 19 coulomb. I am not taking minus because we have to take the magnitude. So N equal to Q by E. So Q equal to plus 8 into 10 minus 19 minus 18 coulomb, and by E and electron charge is 1.6 into 10 minus 19 coulomb, and if we calculate the value will be 50. So it is in integer. So it is an integer. So that's why a charge of 8 can a charge of n be given? Yes, a charge of 8 plus 8 into 10 minus 18 coulomb be given in a body. That's the correct answer. So body can be charged when n value is in integer, and body cannot be charged when n value is not in integer. So yes, thank you. I have class from 9. I've revised my physics. Let him give the link, then I will switch off this. What is neutron? Neutron is made up of equal charge particle, but neutron is neutral. For any neutral body, number of electrons and number of proton is same. That's why its charge is 0. For example, number of electron, number of proton is same. So Q net, consider number of electron is 2e and number of proton is 2e. Means and 2e means minus 2e, and number of proton is 2e. So if we find out the net charge, and net charge will be 0. So neutron is made up of equal number of particles, that is number of proton and number of electron is same. To find out the net charge, we have to consider proton, electron and neutron. Please like and subscribe my channel. I am a dropper. I have passed class 12. I have given 1 year drop. And I'm not the ma'am. I'm not teacher. I have my teacher and my teacher is teaching me and I'm just revising it. He is giving me every concept. Not only me, the students, all the students, okay? And from 9, I have another class. I'm waiting for it. And if you want to see the routine, I can show you. He's taking class every day from 7 to 8 a.m. means from 7 to 8 a.m. chemistry, and from 9 to 10:30 p.m. physics, and Saturday Sunday biology. And all day I'm revising what he's teaching. What's your future goal and your aims? Explain fully. What's my future goal? I'm not telling my goal to anyone. I'm a NEET aspirant, so obviously I want to crack. You have a good knowledge and you have a good figure. Figure? Which figure? Figure in number 1, 2, 3, 4. Please like and subscribe my channel. So let me revise chemistry without wasting time. So bonding in carbonyl compounds. Bonding in carbonyl compounds. So for bonding we need a metal and a carbonyl compound, and metal has 5 orbital, have one orbital should be vacant and 4 orbital is fulfilled, and the d orbital shape is d dumbbell, or it can be termed as double dumbbell shape. So metal has 1 vacant orbitals and 4 fulfilled orbitals. And for the carbonyl compounds, carbon has 1 lone pair, and 1 lone pair means there should be 2 electrons, and 2 electrons form 1 bond, and it has pi star antibonding electron, pi star antibonding orbital. So for a metal there are 4 fulfilled orbitals and 1 vacant orbitals, and for carbonyl compounds there is 1 lone pair, One lone pair means 2 electron, and 2 electron form one single bond and form pi star antibonding orbitals. So how metal carbon sigma bond form? The metal carbon sigma bond is formed by donation of one lone pair of electrons on the carbonyl compound into the vacant orbitals of the metal. So metal carbon sigma bond is formed when by the donation of one lone pair of electron on the carbonyl compounds into the vacant orbitals of the metal. That means the covalent compounds carbon has one lone pair, has one lone pair, and that lone pair is donated to the vacant d orbitals, okay, of the metal, vacant d orbitals of the metal, and that's why it forms sigma bond. And sigma bond forms by head-on overlapping. Sigma bonds formed by the head-on overlapping, and head-on lobar overlapping results in sigma bond formation. And what is metal carbon pi bond? The metal carbon pi bond is formed by the donation of a lone pair from a filled d orbitals of metals into vacant antibonding pi star orbitals of carbon monoxide. That means the metal carbon bond pi bond is formed by the donation of lone pair from d orbitals of metal into vacant antibonding pi star orbitals of the carbon monoxide. That means that from the fulfilled d orbitals, electrons or the lone pairs, electrons means there should be 2 electrons. One lone pair means 2 electrons. Obviously that one lone pair is transferred to the vacant antibonding or pi star orbitals of the carbon monoxide. Carbon monoxide means CO. And though from the fulfilled d orbitals of metal, okay, from the fulfilled d orbitals of the metal, electron is transferred to the pi star antibonding orbitals. That means if we calculate the bond order, and the bond order formula is Nb minus Na by 2, and Na means pi star antibonding orbitals is increasing, so their bond order will be negative, so bond order will be decreased. Though the electrons in the pi star antibonding orbital increases, that's why the bond order will be decreased. If we put the formula, means bond order means Nb minus Na. Nb means number of bonding orbitals minus number of antibonding orbitals by 2, and if we calculate the value will be negative. That's why the bond order will decrease. And it's my morning class revision. I'm revising the morning class one. So metal carbon pi bond, there is sidewise overlapping and back bonding form, and due to sidewise overlapping there will be pi bond, and this led to an effect, and that effect led to known as synergy effect. And the metals to ligand bonding creates a synergy effect, and CO is a CO means carbonyl compound is a strong ligand. It's a carbon, it's also known as carbon monoxide. It's a acid pi ligand, and it's a carbonyl compound. And synergic bonding means when there will be synergic effect, and this bonding leads to bonding helps in strengthening the bond between CO and the metal. The ligands are also known as acid pi ligand. And acid pi ligand example is Cn minus CO, and it's formed by the vacant anti-bonding pi orbitals found. So acid pi ligand is formed when there is vacant anti-bonding pi star orbital found. So application of synergic bonding, there are 2 applications due to its synergic bonding and due to charge density on metal. So synergic bonding means metal carbon bond and carbon oxygen bond, and due to synergic bond, their metal carbon bond means bond energy increases, bond order increases, and bond length decreases. and the carbon oxygen bond energy decreases, bond order decreases, and bond length increases. And charge densities on metals, here also the metal carbon bond is formed, and the bond energy increases. Though the bond energy increases, bond order also increases, and bond length also increases. And the carbon oxygen bond energy decreases, bond order decreases, and bond length increases. So for metal carbon bond, bond energy increases, bond order increases, and bond length decreases. And for carbon oxygen bond, it will be opposite. Okay, so bond energy decreases, bond metal for bond energy decreases, bond order increases. Okay. And for the charge density on metals, for metal carbon bond, the charge density will be negative, greater than 0, and greater than positive. And for charge density on metal, there will be first one is positive, then neutrals, and then negative charge. So synergy effects has affects bond length has very minimum differences. So for example, not example, a question given by my teacher, that if a covalent bond length is CO, in CO is 1.28 Armstrong, then what is the value of CO bond length in FeCO5? And this question I have made mistake. I have given wrong answer, and the correct answer will be, let me tell the options. There are 4 options. First one is the 1.15 Armstrong, 1.128 Armstrong, 1.172 Armstrong, and 1.118 Armstrong. I have given the answer 1.172, and this answer is wrong because the differences should be minimum, and already the carbonyl bond means bond length is given 1.128, so the difference is minimum, so the answer will be 1.15 Armstrong. And compare the carbon bond strength. To compare the carbon bond strength, there are four examples are given, like M in CO whole to the power 6 plus 2, CrCO whole to the power 6, and VCO whole to the power 6 minus, and you have to find out the oxidation number. And when you find out the oxidation number will be X equal to Mn CO6, and so Mn, consider Mn as a X, and 6 into 0, and the charge is given plus 2, so X will be 2, and X indicates the oxidation number of manganese, so Mn plus 2. Similarly, CrCO whole to the power 6 oxidation number is 0, and vanadium CO whole to the power 6 minus oxidation number is minus 1. So we also, as we already know, the charge density on metal, first one is positive, greater than 0, greater than negative. So the answer will be first greater than 2, greater than second, and greater than third. Then let's talk about from coordination compounds, that one main thing we should keep in mind, the pi bond filled electron means we cannot take pi bond like pi star to the pi star 2, we cannot take that. We have to take one, you have to fill one, then another one, and then we have to fill 2, so that's why that's a question. And sigma bond is filled, সিগমা বন্ডের ফিল করা যায় এক একটা করে, পাই বন্ডের ইলেকট্রন ফিল হয় এক একটা করে, অ্যান্ড সিগমা বন্ডের ইলেকট্রন ফিল হয় একবারে দুটি করে. Though we are from West Bengal, our lecture is in English. We take the lecture in English, so English and in Bengali. Just wait, 9:30 start করছি. Okay. Yes, it will be anti-bonding due to, for my own benefit, I have said star. Sorry for that. Pi anti-bonding. Thanks for rectifying my mistake. Limitations of crystal field. Crystal field models successfully explain which property of quotation compounds. The properties are the formation, the structure, color and magnetic property. Crystal field has ligand and that ligand is considered as a point charge. As a result, anionic ligands, that is iodine, fluorine, chlorine, should exert the greatest splitting effect. And what is anionic ligand? The anionic ligand actually are found at the lowest end. That is, the lowest end means the left side, that is the spectrochemical series left side. Anionic ligands does not take into account the covalent character of bonding between metals and ligand. Covalent bond means sharing of electron. Covalent bond means, I don't have time now. I have to revise all, and from 9:30 I have class. Covalent bond means sharing of electrons. Metal and ligands has electrons, that means sharing of electrons. And anionic ligands are some of the weakness of the CFT which are explained by the ligand field theory, LFT, crystals, and molecular orbital theory, that is MOT. Bonding in metals. Metal should be the transition metals. Bonding means the double bond, and metal should be the transition metals. Carbonyl compound means carbon and oxygen has double bond, and for the synergistic effect it should be carbon triple bond carbon. What is homoelectric compounds? The compound, any compounds in which have one type of ligand, that is the homoelectric complex. The compound which are having more than one type of complex, that is the heteroelectric complex. The strong field ligands are CO, NO, NH3, and weak field ligands are fluorine, chlorine, bromine, iodine, and these are all halogens and water. So our tetrahedral complex ligand number, when the ligand number will be 4, it will be tetrahedral complex, and when the ligand number is 6, it will be octahedral complex. Homoleptic complex, only carbonyl compound ligands is related with that compound, and homoleptic carbonyl compounds formed by the most of the transition in metals. These carbonyl compounds have simple and well defined structure. Only one type of carbonyl ligand form. Carbonyl means CO, means it has the strong field ligand. Homoleptic carbonyl compounds. Homoleptic carbonyl compound means tetracarbonyl nickel, and the formula is NiCO4. NiCO4, that means its shape will be tetrahedral, and its hybridization will be sp3. Pentacarbonyl iron, its formula will be FeCO5, and its hybridization will be dsp3, and its structure will be trigonal bipyramidal. Hexacarbonyl chromium, CrCO6, and its oxidation number is 0, and its hybridization will be D2sp3. Yes, though it is ligand number is 6, so it will be octahedral, means its shape will be octahedral. Decacarbonyl dimanganese, its oxidation number will be 0, and it is made up of square pyramid unit joined by MN bond, and it has no bridge bond. It is made up of square 2 pyramidal. It is made up of square 2 pyramidal, and it's unit joined by MN bond. Octacarbonyl dicobalt, for octacarbonyl dicobalt CO2 CO8, it has 2 bridge bond, and it has CO bond bridge, and 2 cobalt CO metal. Yes, mononuclear means when one metal connected with one type of ligand. When two metal is connected with one type of ligand, that is the dinuclear. What is trinuclear? When the three metal is connected with the one type of ligand. And what is tetranuclear? When four metal is connected with the one type of ligand. So what is organometallic compounds? Organo means organic, and it means the carbon, and metals means the transition metal. The compounds in which metal is directly bonded with the carbon, that is the organometallic compounds. And there are two types of organometallic compounds. First one is the ionic organometallic compound. Second one is the covalent organometallic compound. Ionic organometallic compound, ionic means ions, and ions are of two types, cations and anions, and ionic bond is present between the metals and the carbon. Covalent organometallic compounds. Covalent bond means sharing of electrons. Covalent bonds are present between the metals and the carbon. Covalent bonds are three types: sigma bond, pi bond, sigma pi bonded. Sigma bond is formed when there is a single bond, and single bond has two electrons, and two electrons should be unpaired. And sigma bond present between the metals and the carbon. CH3,4SN, that is tetramethyltene. RMGX is the Grignard reagent, that is the organic reagent. And Cm sigma number of total sigma bond between the carbon and metal for RMGX is 5 sigma bond. And for Al2Me6, number of sigma bond for metal and carbon is 8, it's not 9. Okay, so pi bond, the pi bond is denoted by double bond. Pi bond has double bond, and when there is double bond there is one sigma bond and one pi bond, and when there is triple bond there is one sigma bond, two pi bond, and then when there is one bond there is one sigma bond and zero pi bond. For ferrocene, Fe n to the power 5 C5H2 whole twice. So F is the metal and N is the number of carbon in a ring, and that is the linear chain, and hapticity will be 5. So n to the power 5 means hapticity will be 5. And dibenzene chromium means Fe is n to the 5 Fe n to the power 5 C5H2 Fe n to the power 5 C5H2 whole twice 2. Fe n to the power 5 C5H2 or twice 2, that is the ferrocene. And dibenzene chromium is Cr n to the power 6 C6H6 whole twice 2, and its hapticity will be 6. And for this salt, potassium PtCl3 n to the power 2 C2H4 K PtCl3 whole K PtCl3 n to the power 2 C2H4 K PtCl3 n to the power 2 C2H4 K PtCl3 n to the power 2 C2H4 K PtCl3 K PtCl3 K PtCl3 n to the power 2 C2H4 K PtCl3 n to the power 2 C2H4 K PtCl3 n to the power 2 C2H4, and its hapticity will be 2. And for the sigma and pi bond, it occurs between the metal and carbonyl compounds. And NiCO4, its hybridization will be sp3, and its tetrahedral structure MnCO5 dsp3, its structure will be trigonal bipyramidal. FeCO5, its structure will be dsp3, its trigonal bipyramidal. CrCO6 d2sp3 is octahedral. MnCO10, there will be two trigonal bipyramidal. CO2, CO8, and there will be two tetrahedral unit. Now from 9:30 I have class, so I have to take rest for 5 minutes. Carbon. Homoelectric complex, obviously there should be one type of ligand. Carbon oxygen bond concept is important. Scientists recently discovered a rare few element called tritium, and it look like you are made of it. Please like and subscribe my channel.